Boston Dynamics has just unveiled a new Atlas. And finally, we have a product version of Atlas that is not focusing on parkour or jumping or backflips, but on real, useful chores, tasks, and work. For the first time, Atlas is no longer a research experiment. It is being introduced as a humanoid robot built for real work in real environments. Hey guys, Alfie here. Welcome to AI Nexus. We're starting our CES 2026 coverage with one of the biggest unveiled so far, Boston Dynamics' new product version of Atlas, with much more from CES coming next. During a broader presentation by Hyundai Motor Group, where Atlas was positioned as a key part of Hyundai's long-term AI and robotics strategy. This was not a standalone robotics demo. It was a strategic moment, carefully placed inside a larger vision for how artificial intelligence and physical robots will be used across industry. What made this moment important was not what Atlas did on stage, but what Boston Dynamics chose not to do. There were no backflips, no stunts designed to shock the internet. Instead, Boston Dynamics revealed something far more serious, the product version of Atlas. For years, Atlas was known as the most athletic humanoid robot ever created. It could jump across platforms, run outdoors, recover from hard falls, and move in ways that looked almost unreal. Those demonstrations proved one thing very clearly. Boston Dynamics had mastered balance, motion control, and dynamic movement better than anyone else in the field. But those demos were never about daily usefulness. They were about possibility. At CES 2026, the message changed. Atlas is no longer about what robots can do once under perfect conditions. Atlas is now about what robots can do every day, reliably, safely, and at scale. Boston Dynamics has repeatedly described this version as the product Atlas, and that wording matters. A product version is designed to be built, shipped, supported, and improved over time. Design decisions are no longer just about peak performance. They are about durability, safety, and integration into existing systems. Visually, the new Atlas looks more refined. There is less exposed wiring. Protective panels cover more of the body. The robot appears sealed, industrial, and purpose-built. This is not about aesthetics. It is about survival in real environments. The product Atlas is water-resistant, designed to handle washdowns, and built to operate across a wide temperature range. These are features factories require, not features designed for camera demos. Atlas is also designed to be more self-sufficient. When battery levels drop, Atlas can navigate to a charging station and replace its own battery. This allows longer operating periods without constant human supervision. Again, this is not a flashy feature. It is a practical one. In industrial environments, stopping work every hour is simply not acceptable. On the CES stage, Atlas did not lift heavy objects or perform complex manipulation tasks. It stood, walked, waved, and moved its head while tracking its surroundings. The demonstration was calm and controlled. Boston Dynamics openly confirmed that the stage demo was remotely operated. That was not a weakness. It was a deliberate decision. Public stages are unpredictable, and safety matters. The goal was not to prove full autonomy in front of cameras. The goal was to show that Atlas is stable, responsive, and ready to be introduced as a product platform. Boston Dynamics has been clear that Atlas supports multiple control modes. Atlas can operate autonomously. Atlas can be remotely operated. Atlas can also be controlled using a tablet interface. That last point is important. Many humanoid robot demos rely on motion capture suits or VR systems for teleoperation. Those setups are powerful, but they are bulky and impractical for everyday industrial use. A tablet-based control system lowers the barrier significantly. It allows operators without deep robotics training to guide tasks, intervene when needed, and manage workflows efficiently. Factories do not want highly specialized operators wearing complex gear just to control a robot. They want systems that fit into existing processes. Atlas is clearly being designed with that reality in mind. Atlas is just one part of what CES 2026 has revealed so far. There are many more AI and robotics announcements still to cover, and we'll be going through them one by one. Subscribe to stay updated on everything coming out of CES 2026. Now, let's continue. Another major shift with Atlas is software focus. Earlier versions were about movement. The new Atlas is about tasks. That means perception, decision-making, and coordination now matter just as much as motors and joints. Atlas is designed to understand its environment, recognize objects, and execute repeatable actions with precision. Atlas is rated to lift up to 50 kilograms, or about 110 pounds. That places it squarely in the range of physically demanding industrial work. These are tasks that are repetitive, exhausting, or risky for humans. Atlas is not being positioned to replace people. It is being positioned to take on the parts of work that cause injuries and long-term fatigue. For the first time, Boston Dynamics has quietly shown that Atlas is not meant to stay confined to factory floors forever. The way Atlas is now being presented makes it clear that its future is not limited to industrial environments alone. This version of Atlas is being shaped as a general-purpose humanoid, designed to understand human-scale spaces, move safely around people, and operate in environments that are not rigid or controlled. Those capabilities are not necessary if a robot is meant only for factories. They become essential when a robot is expected to work in spaces designed for humans. That shift matters. It suggests that Atlas is being prepared for a world beyond production lines, one where the same intelligence and physical capability could eventually support everyday tasks in human environments. Not immediately, and not all at once, but as a natural extension of what Atlas is becoming. Atlas was revealed at CES 2026 as part of Hyundai Motor Group's broader AI strategy, and Hyundai laid out a clear, phased plan for how Atlas will be used. The first phase focuses on parts sequencing in factories, with early real-world use expected to begin around 2028. These are controlled tasks where robots can add value quickly and safely. The second phase moves Atlas into component assembly. This introduces more complex coordination, longer operating cycles, and tighter integration with human workers. The third phase expands Atlas into heavier loads, higher repetition, and more complex operations across industrial environments. Each phase is designed to build on validated performance rather than rushing deployment. Hyundai has emphasized safety, quality, and validation at every step. This is not a fast rollout. It is a careful one. Boston Dynamics has confirmed that production of the new Atlas begins immediately, with initial deployments planned for 2026. These early units are not meant for mass deployment. They are meant for testing, integration, and refinement inside controlled environments. Atlas is not suddenly everywhere. Atlas is being introduced deliberately. There is also a critical AI partnership behind this shift. Boston Dynamics announced a collaboration with Google DeepMind to integrate advanced AI models into Atlas. This partnership focuses on perception, learning, and decision-making. This matters because modern robots are no longer limited by hardware alone. Training, perception, and decision-making are now the real bottlenecks. Boston Dynamics has acknowledged that recent advances in AI are what made a commercial humanoid robot realistic in the first place. That is why Atlas feels different now. Earlier versions proved what was possible. This version proves what is practical. Atlas is built to be maintained, integrated, trained, and improved. It is designed to work alongside humans, not replace them. And it is entering the world step by step, not all at once. That is why this product version of Atlas matters more than any backflip ever did. If you think that's crazy, wait until you hear this. UBTECH's humanoid robot just went viral for all the wrong reasons. What started as a normal training session inside a robotics lab turned into one of the most hilarious accidents the internet has seen. At the same time, as Jim Fan was discussing NVIDIA's robotics future, Elon Musk jumped in, tweeting, "Optimus Gen 3 is an exquisite work of art, and in Shenzhen, an AI companion with synthetic skin is about to blur the line between machine and human connection." Now, let's start with the fail that made the entire internet burst out laughing. The UBTECH G1 is one of China's most advanced humanoid robots, built to copy human motion with near-perfect precision. But during one training session, That precision turned into pain. Inside a robotics lab, an engineer suited up in a motion capture system to teach the G1 new movements. The setup was simple. Every time he moved, the robot would do the same in real time. The goal was to help the G1 learn complex balance and coordination, the kind needed for martial arts style stances and quick reflexes. But one small mistake changed everything. As the session started, the engineer lifted his leg to demonstrate a front kick. The G1 mirrored the move exactly. The problem? Both were facing the same direction, not opposite each other. So when the man kicked forward, his own foot swung straight up and struck him right in the groin. He collapsed instantly. And here's where it got hilarious. The G1, doing what it was programmed to do, copied his reaction perfectly. It bent forward in the same motion, as if sharing the pain. The whole lab burst into laughter. And within hours, the video hit social media and exploded worldwide. But beneath the comedy is a reminder of how advanced Unitree's robots have become. The G1 has already stunned the internet with its kung fu-style demos, spinning kicks, flips, and lightning-fast moves that prove just how fluid its mechanics really are. It's not a joke robot. It's a serious piece of technology priced at around $16,000, used for AI training and education. Still, this incident shows something deeper. When a robot mirrors us too well, even a simple kick can turn into a perfect storm of precision, timing, and pure comedy. And when we talk about advanced robots, we can't forget Tesla's Optimus. Elon Musk dropped a short reply on X that hit like a thunderclap. Tesla Optimus Gen 3 is an exquisite work of art. And if you're thinking that's just hype, look closer, because that one line is basically Tesla telling the world, this robot is moving into a new class. First, work of art isn't only about how Optimus looks. It's about what Optimus can do with control and precision. Tesla is pushing dexterity hard. Optimus Gen 3 is described as having 22 degrees of freedom in the hand, getting close to human-level arm capability. For fine tasks like uncorking a bottle, that kind of finger control is not a party trick. It's the difference between a robot that can only grab boxes and a robot that can handle real tools, real parts, and real mess. But here's the crazy part. Optimus isn't meant to rely on rigid scripts. The approach described is vision-based learning, using human video data. So Optimus can pick up skills in a more flexible way. That's how Tesla is aiming for a robot that adapts, instead of freezing the moment the environment changes. And don't just stare at the art label. Focus on what the design enables: reliable movement, safe handling, and repeatable work. Now, you've probably seen other humanoids flexing athletic moves online. Unitree's G1 has shown kung fu-style kicks, spins, and even aerial flips. In a recent demo, and Figure's Humanoid has been shown doing quick starts, sharp braking, and even running in earlier clips. So the bar is rising fast. Musk calling Optimus Gen 3 art is Tesla's way of saying, this isn't only about stunts. This is about a robot built for useful capability. And by the way, Optimus Gen 3 is getting close. And if you're excited about it, make sure to subscribe, because we'll be covering it the moment it drops. Tesla's stated goal is mass production in 2026, starting inside Tesla factories, with the potential to scale to huge numbers after that. But autonomy in real, chaotic places is still the hardest problem. So the real question for you is simple. When Optimus Gen 3 finally shows consistent real-world work, will work of art feel like an understatement? And just when you think that's impressive, we still haven't moved on from what Figure 03 did this Christmas. Figure AI's latest humanoid, Figure 03, showed what full autonomy really looks like. And it happened in a simple, real-world setting. In a short clip shared by CEO Brett Adcock, he speaks directly to the robot. "Where were you built?" he asks. The humanoid answers clearly, "I was built right here in San Jose, California." Then comes another question. "Which generation are you?" Figure 03 replies that it's the third generation, calling itself the best, because it has the most advanced features. But here's the interesting part. This wasn't a scripted Q&A. When Adcock asked the robot to hand him a medium and then a large shirt from different baskets, Figure 03 scanned the scene, identified each basket correctly, picked the right shirt, and handed it over smoothly. No joystick, no hidden human operator. It was running fully autonomous vision, reasoning, and manipulation through Figure AI's Helix model, a system where vision, language, and physical movement work as one continuous loop. Instead of separate modules, the robot did pause before responding, about 2 to 3 seconds. That delay caught attention online, with users comparing it to dial-up internet. But that small pause reveals one of the toughest challenges in humanoid robotics: speech latency. Even when robots understand and move perfectly, human-like conversation speed is still hard to match. Technically, Figure 03 is a big leap. It's lighter than previous models, covered with mesh fabric and foam padding for safety, and built for household pick-and-place tasks. It can start, stop, and turn quickly, even run at roughly 4 to 6 miles per hour. It recharges wirelessly through its feet, delivering around 5 hours of operation per charge. So yes, it still thinks for a second before answering. But for a robot that talks, sees, and acts entirely on its own, that pause might just be the sound of the future catching up. In China, Shenzhen-based IO technology is doing something most robotics companies have only dreamed of: bringing the idea of an AI companion from the screen into real life. We've seen expressive robots before, Ameca's facial precision, Sophia's interviews, but IO's project, called Eva.I, goes further. It's not just about appearance, it's about presence. Eva.I is a humanoid robot built to move, breathe, and react like a living being. You can wake Eva.I with a simple touch. The robot blends a physical body with a virtual avatar app, combining vision, sound, and touch with emotional understanding. Eva.I reads tone, expressions, and gestures, reacting not to what you say, but how you say it. What makes this robot so different is its synthetic bionic skin. The outer layer keeps a steady warmth near 37 degrees C, powered by graphene temperature control, while a flexible electronic layer detects pressure and subtle shifts, replicating the sensation of real human contact. Even the breathing motion and micro-expressions are synchronized, designed to make interaction feel startlingly human. The company calls this concept the fourth relationship, an emotional bond without judgment or rejection, a companion meant to support emotional independence, not replace people. Privacy is handled with local encryption, edge processing, and even a detachable camera for safety. Eva.I will first appear through a Kickstarter launch, with just 200 limited units, before moving to global release in February 2026. While IO hasn't revealed the exact price yet, this will likely be one of the most premium companion robots ever offered to the public. A futuristic blend of empathy, design, and embodied AI that could redefine what human-robot connection feels like. Would you ever be comfortable forming an emotional connection with an AI companion like this? Or should that line never be crossed? Curious how you see this future. In China, a new shape-shifting robot has just been unveiled, one that can change its body in real time. And UBTECH quietly crossed a line most companies haven't reached yet. Their 1,000th humanoid robot rolled off the production floor, setting a new benchmark for large-scale deployment. In a lab, a small humanoid robot went head-to-head with a human in badminton, holding its ground rally after rally. On December 18th, LimX Dynamics introduced a robot called Tron-02. The central idea was simple but risky: a robot that can change its body in real time. Not through software, but through physical reconfiguration. Shape-shifting robots sound impressive, but in practice, most robots are locked into one body, one role, and one set of limits. Once the hardware is built, flexibility usually ends. So when LimX Dynamics introduced Tron-02 as a robot that can physically reconfigure itself, the real question wasn't how it looks. It was whether that flexibility survives real-world stress. Because changing form isn't just modular parts. It's balance, it's control logic, it's safety systems that don't fall apart the moment the robot moves differently than expected. That's exactly where most modular robots fail. Tron-02 avoids that trap by being designed around a true tri-form architecture from the start. The same core system can operate as a dual-arm manipulation platform, a wheeled leg mobile system, or a full bipedal walker. This isn't a cosmetic swap. Each form is meant to handle a different class of tasks, from precise manipulation to terrain navigation, without breaking the control stack underneath. But flexibility alone doesn't mean much if the robot can't handle real load. And this is where LimX Dynamics chose a very bold way to prove their point. In one demonstration, Tron-02 appears without legs, suspended only by its arms. It grips a gymnastic ring, the kind used in strength training, and hangs freely in the air. At first, the test looks controlled and simple. 2 water bottles are attached to the robot's body. Tron-02 pulls up. Each lift looks deliberate, almost calm, like the robot is being warmed up rather than tested. Then the moment changes. A young adult woman sits down on a seat that is connected to Tron-02's body, her full weight now hanging beneath the robot. And then Tron-02 pulls up again, lifting the entire woman off the ground using only its arms. No legs, no external support. Just controlled, repeatable strength. And once you accept that strength, the next limitation becomes controlled. Advanced robots don't fail because they lack power. They fail because humans can't interact with them cleanly. Delay ruins coordination. Even small latency breaks manipulation, especially in research environments where precision matters. Tron-02 addresses this with ultra-low latency teleoperation, officially rated at around 100 milliseconds. That means when a researcher moves, the robot responds almost instantly. No lag-induced hesitation, no delayed correction. It feels direct, and that matters when the goal is training embodied intelligence, not just moving hardware. But LimX Dynamics didn't stop at control. They looked at the workflow problem too. Most robotics labs don't struggle with robots. They struggle with fragmentation. Data collection in one place, annotation somewhere else, training on another machine, deployment through a different system. Tron-02 collapses that entire pipeline into a native vision language action platform. Data collection, cleaning, training, inference, and task management all live inside the same environment. LimX even claims that new users can start working with VLA models in just 2 hours, not weeks. And that design choice leads to something unexpected. Visually, Tron-02 doesn't look like a humanoid robot at all. It looks like a modern desktop PC tower that decided to grow legs. Online, people immediately noticed. Comments started rolling in. I didn't know I needed a PC with legs until now. It looks like someone's gaming PC walked off the desk. A PC case learned how to rollerblade. It's funny, but it's also accurate. Tron-02 doesn't pretend to be human. It looks like what it actually is, a developer machine with mobility. A computer-first platform that just happens to move through the world. And that design philosophy shows again in motion. The robot demonstrates controlled dynamic movements, including complex transitions that demand tight coordination across multiple joints. These aren't flashy stunts for attention. They're proof that the control system stays stable even when movement gets aggressive. And in another factory in China, UBTECH quietly crossed a line most humanoid companies haven't even approached yet. The company completed production of its 1000th Walker S2 humanoid robot. Not promised units, real robots built inside a working factory. More than half of them are already delivered and operating. That number matters because humanoid robotics doesn't fail on intelligence. It fails on repeatability. Building one robot is engineering. Building 1,000 is an industrial discipline. And UBTECH isn't slowing down. The company has openly stated its target, 10,000 humanoid robots by 2026. That's not a research goal. That's a supply chain goal. It implies standardized parts, validated assembly lines, and robots that don't need constant babysitting. Of course, scale invites scrutiny. When UBTECH released a polished video showing rows of Walker S2 robots being delivered, skepticism erupted. Brett Adcock, the CEO of Figure, publicly suggested the footage looked like CGI. Too clean, too synchronized, too perfect. Instead of debating online, UBTECH responded the hard way. They released a behind-the-scenes video shot in a single drone take. No music, no cuts, no cinematic polish. Just raw factory footage showing robots moving, loading, and operating in real conditions. The message was clear. These robots are not renders. They're inventory. But Walker S2's most important breakthrough isn't production numbers. It's uptime. One of the biggest hidden costs in robotics is charging. Robots stop. Humans wait. Work halts. Walker S2 removes that bottleneck with something the industry hasn't seen before: autonomous battery swapping. When power runs low, the robot navigates to a station, removes its depleted battery using its own arms, installs a fresh one, and resumes work. No human intervention, no shutdown, no dead time. With a dual battery system, Walker S2 can operate continuously, effectively 24 hours a day. So far, robots have been working. Now, one of them decided to play. In a Chinese lab, Phibot C1 went head-to-head with a human in badminton, matching pace shot after shot. Watching it play, you'd think it had been practicing for a medal. The Phibot C1 demo looks playful. A small humanoid robot rallies with a human opponent on a badminton court. No protective cages, no pauses, just back and forth motion. But what makes this moment historic is what isn't happening. There is no teleoperation, no slowed down footage, no humans pulling strings behind the scenes. The robot is making decisions on its own, in real time. Badminton is a brutal test for robots. The shuttlecock changes speed, direction, and spin unpredictably. Reaction windows are measured in fractions of a second. Even humans struggle to read it consistently. To survive that chaos, the Flybot C1 relies on autonomous anticipation. It doesn't wait for the shuttlecock to arrive. It predicts where it will be, how fast it's moving, and how much time remains before impact. Then commits its entire body to the response. This is real-time sparring, not scripted motion. The robot shifts its stance, rotates its torso, adjusts its footwork, and swings with human-like timing. Movements feel natural because they're learned, not animated. There's no visible hesitation, just continuous flow. And unlike humans, the C1 doesn't tire. Performance stays constant, reaction stays sharp, precision doesn't fade. Rally after rally, the robot delivers the same output without fatigue, frustration, or error accumulation. Surrounding the court is another clue to what's happening. A large metal scaffold holds dozens of cameras tracking the shuttlecock in three-dimensional space. This isn't decoration, it's perception infrastructure. The environment feeds the robot exact position and velocity data, allowing it to respond faster than human reflexes ever could. But the most important detail is philosophical. The Flybot C1 isn't trying to look impressive. It's trying to feel alive. When the robot reacts instantly, adjusts mid-motion, and recovers naturally, something clicks. This isn't task automation anymore. This is embodied intelligence responding to a human in a shared physical space. And if robots can now react, predict, and move like this in controlled spaces, Japan is already asking what happens when that intelligence leaves the lab and enters everyday life.